Hi everybody, here is your lesson for Chapter 3, Lesson 3, Angles of Polygons. Learning targets are to find interior angle measures of polygons. To be able to explain how to find the sum of interior angle measures is a success criteria. Find an equation for interior angle measures of polygons is another success criteria, and I can find the interior angle measures of regular polygons. A polygon is a closed plane figure made up of blank or more line segments that intersect only at their end point. In order to have a polygon, we must have 3 or more line segments. And so examples of polygons on the left here, non-examples of polygons on the right. So based off of that, you try it, draw a figure that is a polygon, draw a figure that is not a polygon, and then answer why is it a polygon and why isn't it a polygon. So answers here will vary. Obviously, you probably chose to draw different polygons. Here's my polygon. Why is it a polygon? Because it has 4 line segments. To create my shape. Draw a figure that is not a polygon. And why is it not a polygon? Because it doesn't have 3 or more line segments. So now I'm going to ask you to stop and complete this discovery task. It should be in your student journal. Please continue this discovery task prior to continuing with your notes. So now that you've completed the discovery task on your own, I'll talk you through these questions. What is the sum of the angles in a triangle? We know that it's 180 degrees. And I demonstrated for you in class how I took a triangle and how I tore off each of the 3 corners. And when I put those angles together, those angles all formed a straight line. So it looked like this. And we know that a straight line is 180 degrees. So all of my angles would add up to 180. How many triangles fit in a shape? Well, if we take this quadrilateral and we cut it in half, now we have 2 triangles, 180 degrees and 180 degrees of interior angle sums. A pentagon, we can split that up. And in this 5-sided pentagon, we now have 3 triangles. And here we have a hexagon, so we can also split this up into triangles. And while the triangles are not all the exact same shape, they are all triangles still. And we know that any triangle has an interior angle sum of 180. So, into our table. A quadrilateral has 4 sides. Number of triangles formed would be 2. And the sum of your interior angles would be 2 times 180, which is 360. A pentagon has 5 sides, 3 triangles can be formed, and so 3 times 180 is 540. A hexagon has 6 sides, 4 triangles can be formed, so 4 times 180 is 720. A heptagon, 7 sides, 5 triangles. So 5 times 180, 900 degrees of interior angle sum. And an n-gon, number of sides would be n. Number of triangles would be n minus 2, because every one of these number of triangles is 2 less than the number of sides. And so then the sum of the interior angles, n minus 2 times 180. How does drawing triangles from one vertex help you find the interior angle sum of any regular polygon? Well, it creates triangles. And every triangle has 180 degrees of interior angles. Write a general equation that could be used to find the total interior angle sum based on the number of sides. That would be the n minus 2 times 180. So that is going to be your equation that you use for the rest of this lesson. And here it is, just again, as your key idea. So now let's try example 1. Find the sum of the interior angle measures of a school crossing sign. How many n sides does the shape have? So let's pick a vertex and let's cut this thing up into some triangles. So we can see that it has 5 sides. So 5 minus 2 is 3 triangles. So 5 minus 2 is 3 times 180. So 3 times 180 is 540. And then distribution. Find the sum of interior angle measures of this honeycomb from a beehive. So this has 1, 2, 3, 4, 5, 6 sides. So n minus 2 times 180, that's 6 minus 2, which is 4 times 180 is 720 degrees. Now you try it. Find the sum of the interior angle measures of the green polygon. Then when you're ready, hit play. So this green polygon has 1, 2, 3, 4, 5, 6, 7 sides. So n minus 2 times 180, that's 7 minus 2 times 180, or 5 times 180. And 5 times 180 is 900 degrees. Next, we move to finding an interior angle measure of a polygon. Find the value of x. Step 1, find the sum of the interior angle measures. So first of all, we need to know how many sides we have. 1, 2, 3, 4, 5, 6, 7. That's nice because we just did one like that. So n minus 2 times 180. 7 minus 2 times 180. So that's 5 times 180, and we know that was 900. So 900 equals all of these angles added up. So we'll do that. 140 plus 145 plus 115 plus 120 plus 130 plus 128. That equals 778 plus x. That's the one we don't know. So now we take away 778 from both sides. And we get 122. So step 2 we just did, write and solve an equation to solve for x. X is 122 degrees. Now you try it with these next two. First off, for number 3, count the sides. 1, 2, 3, 4, 5, 6. So 6 minus 2 times 180 is 4 times 180. So that's 720. And now we have to add up all the angles that we do know. 135 plus 110 plus 125 plus 120 plus 125. That all comes out to be 615. 615 plus x. Take away 615 from both sides. So we get 105 degrees equals x. And for number 4, we have 1, 2, 3, 4 sides. That is a quadrilateral. And so we know that has 360 degrees. And now let's add up our angles, 90, 80, and 115. 80 plus 90 is 170, plus 115 is 285, plus x, minus 285 from both sides. And so 360 minus 285 is 75 degrees. In our next set of examples, we don't have pictures. A hexagonal shelf you want to make has interior angle measures of 100, 100, 140, 140, 135 degrees, and x degrees. Write and solve an equation to find the missing angle measures. So this is exactly like the last ones, just no picture. So it says a hexagonal shelf. That means 6 sides. So 6 minus 2 times 180, and 4 times 180. That's 720 degrees of interior angles. Now we'll add up. 100 and 100 is 200, 340, 480, and then 480 plus 135 is 615, plus the missing value of x. So take away 615, take away 615, and you get 105 degrees equals x. In this next example, it says an octagonal shelf you want to make has 4 angles that are all x degrees. The sum of these 4 angles is 500. So we know we have 4 angles, 500 degrees. So let's just do 500 divided by 4. So the 4 angles all have a measure of 125. So let's just label those. 125, 125, 125, and 125. Okay? The other 4 interior angles all have the same measure. So let's say that's M, 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 and M. Find the measure of all the interior angles. Okay, so it's an octagon, so we know it has 8 sides. So 8 minus 2 times 180. 6 times 180. 6 times 180 is 1,080. So now we can solve. 1,080 equals 4m plus 500. Take away 500 from both sides. we end up with 4m equals 580. Divide both sides by 4. And m equals 145. So now we can come back and we can say these m's are all 145 degrees. The ratio of interior angles of a triangle are 4, 5, 6. So what are the angle measures? So if we draw a picture here, we say this is 4, this is 5, and this is 6. Could add a variable in there. 15x equals 180. Divide both sides by 15. So 180 divided by 15 is 12. And so now we can do 6 times 12 is 72. 4 times 12 is 48. And 5 times 12 is 60. And now if we add 72 plus 48 plus 60 together, we get 180 degrees. So here are your 3 angle measures for your triangle. Now for our modeling real life. It says a cloud system discovered on Saturn is the approximate shape of a regular hexagon. Find the measure of each interior angle. So a hexagon is 6-sided. That is not a perfect hexagon by any means. Definitely not a regular, because a regular hexagon means they have all the same exact sides. But what we do know is that it has 6 sides. So 6 minus 2 times 180 gets us to 4 times 180. 4 times 180 is 720. And 720 then, divided by 6 sides, means that each of the angles is going to be 120 degrees. So now you try it. You're designing a new logo for a local business. The shape of the logo is a regular nanogon, which is 9-sided. So what is the measure then of each interior angle of the logo? So we start with a 9-sided shape. I'm going to do you a favor. I'm not even going to try to draw this. I'm just going to go 9 minus 2 times 180. So 7 times 180 is 1,260 divided by 9 sides. So each interior angle is going to be 140 degrees. And now one more, try it. This one says the interior angles of a regular polygon each measure 135 degrees. How many sides does the regular polygon have? Show your work.